Hi everyone, this is the notes for 7.3, area and circumference of circles. So for these notes, there's two foldables that we're actually going to work on, the circumference and arc length and the area of a circle and the area of a sector. They go together in one note for 7.3. There's just two foldables for them, so make sure you have both of them. So let's start by talking about circumference. This hopefully will be a review for you. So the circumference is the distance around the shape, or distance around the circle, because circumference only goes for circles. But I used the green highlighter to show you what the circumference of the circle would be. So if we unrolled the circle, it would be how long the string would be that would go around it. So we have two formulas, one that uses the diameter and one that uses the radius. So we could do pi times the diameter. So diameter is the length all the way across. Or we could do 2 times pi times the radius, and the radius is half across the circle. So if we know the radius to get the diameter, you just double it. If you know the diameter to get the radius, you would divide it by 2. So it really is whatever formula you like to use more, you can find the diameter or the radius no matter what you were given. Okay, so let's try our first example. Over to the right, example 1, part A. So we want to find the circumference of each circle. I know it says use 3.14 for pi. We're going to leave it both that way and with the pi in the answer, which is what your worksheets are going to say. I like leaving it both because you never know what tests they're going to ask you for, so it's better to be familiar with it. So our first example, they told us that the radius, or they showed us that the radius is 7. So we're going to use the circumference equals 2 times pi times r, since they gave us the radius. So 2 times 7 times pi would give us 14 pi millimeters. Or if we plug 3.14 in for pi, we would have 14 times 3.14. And so we end up with 43.96 millimeters. So that's what I was talking about, the two answers. One in terms of pi and one using 3.14 as an approximation. Sometimes they might ask you instead to use your pi button on your calculator and then round your answer, and that would give us a different value. See how we end up with 43.98. So be careful and make sure you use whatever is asked for you. The reason that it's different is because there's a lot more digits of pi that they're using, which adds more to it. Okay, so go ahead and pause and try part B. Okay, so for B, we should have ended up with 5 pi, or 15.7 feet. Okay, so for example 2, they ask us to find the radius. So for these, we're going to be working backwards. So we know that the circumference equals 2 pi r, and they gave us the circumference, so we're going to plug it in for the circumference and try to find the radius. So I'm going to plug in 3.14 for that pi. Oh, we forgot the 2. 2 times 3.14. And then we would just solve this equation and we would know the radius. So instead of giving us the radius, asking for the circumference, they're giving us the circumference and asking for the radius. So we just plug in what we know into the formula and solve. So we'd have 56.52 equals 6.28 r, and then divide. So the radius would equal 56.52 divided by 6.28, which is 9. So our radius is 9 meters. So the same thing for part B. For example 3, they're asking for the diameter. So we would do the same thing, except I would use this formula instead. You could use this one, you would just have to times your radius by 2. So if we plug this in, it would just be 6.9 or 69.08 equals 3.14 times the diameter. So finding the diameter is just a little bit less work. So then you would just have to divide by 3.14. So 69.08 divided by 3.14, gives us a diameter of 22 centimeters. So go ahead and pause and try those other two that we left blank. Okay, so if we get, we should have got 4 and then 15. So make sure you circle those and ask questions if you didn't understand. Okay, so arc length is just like circumference, but instead of finding the whole circumference all the way around the circle, what we're doing is actually finding only a fraction of the circle. So it all depends on what angle measure we're given in the center, okay? But that's a portion of the circle. For instance, if we were given an angle measure of 90 degrees, what fraction of the circle would we have? Well, I hope you thought of it as like your splitting it into fourths. So 90 degrees out of the whole circle would give us 9/36, which is 1/4. So 90 degrees is a fourth of the circle. Like if you folded it in half and then in half again, you'd have your 90 degrees. So this is what we're looking for. What fraction of the circle circumference do we want? Okay, and there's an easier formula than trying to figure out those fractions each time. So we just take the arc length that they gave us, put it over 360, kind of what I just did here, and then times it by the circumference formula. So this tells us what fraction of the circle we're looking for, and then we just times it by the circumference. Okay, so for example 4, we want to find what this arc length is here, that arc AB, which is 70 out of 360 of the circle. Okay, we know if we wanted to find the whole circumference, we would do 2 times pi times 9. So the whole circumference is 18 pi. We don't want the whole circle. We only want 70 degrees out of 360 degrees of the circle. Okay, so we're going to plug this in just like this. So 70 out of 360 times the circumference, which is 2 pi r. So 2 times r times pi, or 18 pi. And then we would just simplify that. I like to leave these in terms of pi. I know it says use 3.14, but we're going to leave it with the pi's for now. Okay, so if we reduce our fraction, we have 7/36 times 18 pi, which we can reduce again because 18 goes into 36 twice. So this would be 7/2 pi centimeters, not squared, just centimeters. We can plug in 3.14 for pi. So 7 divided by 2 times 3.14 would give us 10.99 centimeters. So you have in terms of pi and as a decimal. If you got stuck at this point, all I would have done was 7 times 18 and then divided by 36 to reduce it. So whatever that number was. 7 times 18. So 126/36, and then reduce that fraction, and you get 7/2. Okay, so for the examples below that, we are, again, working backwards. So for example number 5, they tell us what the arc length is, but they want us to find the angle. Okay, so remember the arc length equals the angle, or the arc, over 360 times the circumference. Okay, so the arc length equals the arc, or the angle, over 360 times the circumference formula, 2 pi r. And r is 6. Okay, so there's a couple different ways to go about this. I am going to multiply by 360 on both sides to get rid of that fraction. So 5.75 times 360 is 2070. So 2070 equals 2 times 6 is 12 pi times our variable, the arc. So since we're using 3.14, I'm going to times 12 by 3.14, and I get 37.68. So we have 2070 equals 37.68 times the arc. And then I would just divide to see what that arc is. And really it's our angle. You can call it your angle too. I think that's what I did last year. So 2070 divided by 37.68 gives us that our angle is 54.94 degrees. So example B is just like example A. So let's look over at example 6. So this one is a little bit different. They want us to find the circumference of the whole circle. They gave us the fraction and what that fraction circumference is. So if this would have been 90, we would have just had to multiply it by 4 because we would have known that it was 1/4. Okay, for these, it's all you have to do is set up a proportion. So the fraction of the circle that we had was 80 out of the whole circle. And their circumference for the fraction was 57.5. And what we want to know was the whole circumference. So the angle out of the whole circle equals that circumference, that arc length, out of the whole circle. And if we cross multiply and divide that proportion, then you will know what the whole circumference is. So we end up with the circumference equal to 258.75 kilometers. Okay, so make sure you finish those other 3 examples and we'll talk about them in class. So let's go to our second foldable, which is about area. Okay, so the formula for area of a circle is pi r squared. We're also going to talk about the area of a sector, and a sector is like the slice of pizza. So if we were to cut out a slice of pizza, the area of that slice. I usually describe the arc length as the crust of the slice of pizza. So the sector is the whole pizza, arc length is the crust. Or the sector is the whole slice. So the formula for this is just like for arc length, the arc over 360, but this time we're timesing up by the area formula since we want the area of that slice. So let's look at our first example. So we're finding the area of the circle. So the area formula is pi r squared. When I fill that in, I usually put like 12 in front of the pi, just because it looks funny the other way to me. So this would be equal to 144 pi centimeters squared. And if we plug in 3.14 for that and approximate, we would get 452.16 centimeters squared. Okay, so for example 3, they want us to work backwards to find the radius. So we'd plug in the area that they were given and then solve for r. So we would have 379.94 equals r squared times 3.14. For these problems, since it says use 3.14 for pi, we have to plug it in that way. So then we would just solve our equation from here. So what would you do first to get r squared by itself? Very good. We would divide by that 3.14. So when we do that, we end up with 121 equals r squared. Take the square root. So 11 is the radius, or 11 miles. Okay, so let's practice example 5 and 7, and then you can try those other examples on your own. So this time we want the area of that sector. So just like with arc length, we're going to take our fraction of our circle. So 62 out of 360, 62 from there. And then we times it by the area formula, which is pi r squared. So r squared times pi. So I like to reduce my fraction and go that way. I know it says to plug in 3.14, but we're going to keep it in terms of pi first. So 60 over 360 can be divided by 2. So we would end up with 31 over 180. 4 squared is 16. I know that I can reduce those two. They can both be divided by 4. So I would have 31 times 4 pi over 45. So now I can multiply straight across, and then I would end up with 124 pi over 45 inches squared. And if I plugged in 3.14, what I would do is 124 times 3.14, which my calculator gives me a fraction, and then divide it by the denominator. So this is approximately 6.52. 124 times 3.14 divided by 45. Oh, yeah, 8.65. It says to round to the nearest tenth, so it would just be 8.7. So 8.7 inches squared. Okay, so let's take a look at example 7 so you can see one of those and then you can finish the rest on your own. So this is doing just what we did on the last one, but we're going backwards. So they're trying to find the radius. Okay, so remember the area equals the angle over 360 times pi r squared. So our area equals the angle over 360 times pi r squared. And since we're using 3.14, I'm going to just plug it in right now. So times 3.14 r squared. So you can go about this a lot of different ways. Like I did on the other example, I like to multiply that 360 out first, just because it makes no fractions. So that's probably what I would do here too, unless it gives us like a repeating number, and then I usually won't do it that way. Oops. So 64.11 times 360. So we have 23079.6 equals 150 times 3.14, 471 r squared. And then we would divide. So I get that crazy number, which I'm not going to write down. Like, so 49.00127 blah, 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 equals r squared. So what would you do from there to get r? Very good. We would have to take the square root of both sides. So when you're doing this, I would just leave that whole number in your calculator. So if you have one of these fancy ones, you can hit answer, the answer button at the bottom, and it types it all back in for you, the whole thing. So since we have a bunch of decimal points after it, we're just going to, if we rounded to the 10th, 100th, or 10,000th, we wouldn't have anything. So I'm just going to write that r is equal to 7. Okay, so go ahead and finish those other examples for your notes, and we will work on them in class tomorrow or in our